This is a DBI Pi, our endgame desktop computer. Here's why we built it, and everything you need to build one yourself. We wanted to build a computer that lasts, something modular, upgradable, and with a bit of personality. The frustration was simple. Most compact computers are sealed units. When the hardware inside becomes outdated, the whole thing goes, including any peripherals built into it. There's no upgrade path, just replacement. We just knew there was a better way. So we built one. Don't get us wrong, this isn't a breakup with computers that have built-in keyboards. It's more of a let's see other people conversation. All-in-one keyboard computers are great for a lot of people. One cable, everything included, plug in and go, that's valuable. We're just not those people. Because when the next hardware generation lands, the whole thing goes, keyboard included. You don't get to keep it. And that feels like a problem worth solving. So we set 3 rules before starting to design the computer. Rule 1, the keyboard is not part of the computer. Rule 2, it's as future-proof as possible, in that the case outlasts the hardware inside it. Rule 3, whatever we build, we share the recipe, so people can make one themselves. That second rule pointed us straight to the Raspberry Pi compute module. Think of the Raspberry Pi compute module like a stick of RAM, except it's the entire computer, processor, memory, everything, packaged onto something about the size of a credit card, or a custard cream. The compute module connects to a carrier board. The carrier board is the base that gives the compute module access to the ports, storage, and power. The module is the brain. The carrier board is everything the brain needs to talk to the outside world. The compute module was designed for industrial machines that are built to last, things that need to keep running for years to come. For the thing that we're building, the same modular approach applies. When upgrading, the case stays, the keyboard stays, only the brain upgrades. That's the system. Now, let's talk about the box that it lives in. Function was the easy part. Visual character was harder. We wanted a computer with personality, something you actually wanted to look at every day. So we went back about 30 years and found the Silicon Graphics Indy, a professional workstation introduced in 1993 and used in VFX studios and research labs all over the world. If you worked with serious graphics in the 90s, you knew it or you used it. Every other PC back then was a beige rectangle. The Indy was angular, wedge-shaped and teal, almost periwinkle, impossible to mistake for anything else. It looked fast even when it was switched off. It had a presence. That sense of character has been almost entirely abandoned from modern computing. The aesthetic consensus for the last 2 decades has been make it look like nothing. The Indy was never interested in that consensus, and neither are we. Side note, the Indy had a brilliant boot-up sound, so if we're building something like it, it needs to have an integrated speaker. The brief was, shameless homage, not replica. Something that announces itself, something that you want to look at every day. Where the old case said Silicon Graphics, ours bears the name of our mythical hardware company, Dirtboy Industries. Founded in nobody's garage, building machines nobody asked for. Dirtboy Industries. We designed in FreeCAD, a free open source 3D design software which felt appropriate for a project built entirely around not being locked in. And because the files were always going to be shared, designing in open source software meant anyone can open them, no license required. Goals from the start: horizontal desktop orientation, low and wide under the monitor. Front vents echoing the Indy grille geometry, functional but intentional. A rear panel that opens without heroics, components should be easy to get to. And finally, passive cooling, generous airflow before a fan gets anywhere near the conversation. Storage is handled by an M2 SSD, a small, fast, solid-state drive slotting directly into the carrier board. The case is 3D printed, and the choice of material matters more than you might think. We asked around and here's what we found. PLA, the most common printing material, softens around 60 centigrade. Fine for prototypes, not for something sitting on a desk under a monitor for the next decade. PETG handles heat better than PLA, but can be fussy with paint and UV exposure. We use ASA. Tougher, holds its shape to around 100 centigrade, resists UV yellowing and takes paint evenly. Slightly more demanding to print, but this case is meant to outlast several generations of Pi hardware, so it earns the extra effort. The colour nods to Silicon Graphics Indy Teal. Not a copy, but recognisable in the same family. Before assembling the parts, we spray the 3D printed case with acrylic paint. Patient thin layers. The logo is cut using a Cricut onto permanent matte vinyl. The badge is 3D printed and coated in silver paint. The SSD goes into the carrier board before the carrier board goes into the case. Compute module clicks in firmly. And the amplifier board and speakers are attached to the lid and the carrier board's hat. Backplate on. Done. Power on. The sound quality from the built-in speaker is surprisingly good. Raspberry Pi OS boots to the desktop in seconds, responsive, quick and eager. The keyboard is whatever you want it to be. Our choice changes occasionally depending on who is using the computer. That flexibility is baked in. And everything you need to build your own, FreeCAD files, hardware lists, print settings, paint references, build notes, it's all in the description. If you build one, let us know and tell us in the comments what keyboard you paired it with. We'd love to hear about it. Thanks for watching.